So let's work a projectile motion problem. A ball is thrown at 40 meters per second at an angle of 53 degrees above the horizontal. So here's the horizontal, and here's the direction the ball is thrown, right? We're going to call that theta equals 53 degrees, and we're going to call this V naught equals 40 meters per second, right? We have all these equations that we've come up with. X equals x naught plus v average x times time, and vx equals v naught x equals v average x. Those are the two x equations. Remember, we reduced all the 5 equations down to 2, and so we can call those 1 and 2. And then we have all the y equations. Y equals y naught plus v average y times time. 2 is vy equals v naught y minus g times time. 3 is v average y is equal to vy plus v naught y over 2. And then the two equations that are from the other ones, y equals y naught plus v naught y times t minus 1/2 g t squared. Is that still on the screen? And then 5 is vy squared equals v naught y squared minus 2g times y minus y naught. And so I've got really 7 equations, 2 in x and 5 in y for every projectile motion problem. But when I look at this problem, this velocity is not either in the x direction or the y direction. It's called v naught, and I can't plug it into any of these. And so I have to adjust this problem so that my tools will work on it. And that's what this question is basically telling me to do. It's saying, find the x and y components of this velocity. And so if I, it was terrible. I'll fix that in a minute. Right. This is v naught y. It's just a y component of that. And this is v naught x. The initial velocity is that way at 53 degrees. And that means not all of this velocity in the y is in the y direction, and not all of it's in the x direction. V naught y is just v naught times the sine of 53 degrees. And that's that one's 32 meters per second. That's v naught y. And then v naught x is v naught cosine 53 degrees. And so that's 40 times and that's 24 meters per second. And so now I have an initial velocity in the x direction and an initial velocity in the y direction that I can begin to plug into these formulas. And so I'll leave those formulas there, and I'll just ask different questions along here. So this is again my v naught y, and I can say, here's my v naught y, and there's my v naught x. And so instead of asking what are the components, we've done that already, right? I'll say So how long until the ball reaches its maximum altitude? I'm asking for the time, right? Time equals question mark. And so this ball is going to follow some arc, right, like this, like that. And this is when it reaches its highest altitude. And so what do we know about what it's doing at its highest altitude? Well, its y motion has come to a stop. And so at this point, Vy is equal to 0, right? We already know that V naught y is 32 meters per second. And so the question is, what is t? And so I can just look through these formulas and say, well, look, this formula gives me time, gravity, V naught y, and Vy. And so if I rearrange formula number 2, I get time is equal to V naught y minus Vy over g, or 32 meters per second minus 0 over 10 meters per second squared, or t equals 3.2 seconds. So at 3.2 seconds, it's reached maximum altitude. Right. So now I can ask the question, what's its horizontal displacement this time? I'm saying, look, when it's at its maximum altitude, what is its x position? If we're picking x naught equals 0 here, then this would just be x, but at any rate, it's x minus x naught. And so that's what we're asking about. Well, I only have one equation for x, right? This equation 2 is just for the velocities. And so I have to use this equation, right? And so x minus x naught is just equal to v average in the x direction times the time. But we already know what this is, right? This is 24 meters per second because the x velocity never changes. And we already found that v naught x was 24 meters per second times 3.2 seconds, right? Which is 76.8 meters. And so in 3 seconds, it's traveled 76.8 meters horizontally when it got to its maximum height. Then I can ask, well, what's its vertical position at this time? Right, here it is again. Right, it's at this spot. It's getting ready to come back down. Right, this is y minus y naught. Right, there are a bunch of ways to calculate this, but equation 5 looks pretty good, right? I can say, look, so I'm going to erase this for a second so I have a little room to work here. And I'm going to say Vy squared is equal to V naught y squared minus 2g times y minus y naught. Vy is its velocity at the top position, right? And that's 0. And so this just says V naught y squared is equal to 2g times y minus y naught. This is the thing we're after, and so y minus y naught is equal to V naught y squared over 2g, right? V naught y was 24 nope, 32 meters per second over 2 times 10 meters per second squared. There it is. Right, and so that's 32 squared is 964. No, 1024. 1024. Divided by 20. Was that 51? Yeah. So the height it reaches is 51 meters, and so its x position we calculated a minute ago to be 76.8 meters, and its y position was 51 meters at the top. Right. I'll just erase some of this. How long is it in the air? Right. The time in the air is just twice as long as the time it takes to get to the highest point, because it's going the same speed up as it is coming down. It just reverses itself. We talked about that already. And so that's 2 times 3.2 seconds, which is 6.4 seconds. This is like, I don't know what this is. This isn't B. This is like maybe C. This must be D or E. Right, how far does it travel horizontally? Well, x equals x naught plus v average x times time. This is just x minus x naught equals 24 meters per second times 6.4 seconds, which is about 153 meters or something like that. It's twice as far as it was to get to the top, which was 76.8. And so so we can answer all kinds of questions about this. We can pick any time until I can say F. I can just ask the question, what is this y velocity at 5.0 seconds, right? And so that would just be, say, this equation, right? If I come up here and erase these guys, I could say Vy is equal to V naught y minus g times time. That's equal to 32 meters per second minus 10 meters per second squared times 5 seconds, right, which is 32 meters per second squared minus 50 meters per second. Sorry, 32 meters per second minus 50, which is minus 18 meters per second. This shouldn't surprise us that it's got a negative velocity, because it's coming back down. We said it was traveling up for the first 3.2 seconds, and then after that it's coming back down until it gets to 6.4 seconds. So its y velocity is now in the negative direction. It's coming back down, and it's so if I ask the question G, this should be a really easy question, right? The velocity at any time doesn't change. The final velocity in the x direction equals the initial velocity in the x direction equals the average velocity in the x direction. So Vx is equal to V naught x, which is 24 meters per second. So we could just answer all kinds of questions about the trajectory of this ball and what direction it's going and so on. So a ball is thrown horizontally off a bridge. So here's the bridge, and here's the water below. And the ball is thrown horizontally this way. V naught equals 30 meters per second. Right? And so it does this, and it hits the water. And so the first question is, how long does it take to get to the water? Right? And so hopefully somewhere you have your equations. There are 2 equations for projectile motion for x and 5 equations for y. And this is a question for how long it takes the ball to hit the water. And so you have to recognize that that's a y motion problem. The x motion doesn't matter for that. It's just like the demonstration I did with the ball and the ring, where the ring is dropped and the ball is sent out at the same time. The time it takes the ball to hit the ground is the same time as the ring. And so you just have to look at your y equations. And one of the y equations is, well, let me just write them all down here. Y equals y naught plus v average y times time. Vy equals v naught y minus g times time. V average y equals vy plus v naught y over 2. Y equals y naught plus v naught y times t minus 1/2 gt squared, and vy squared is equal to v naught y squared minus 2g y minus y naught. And so we're asking for a time, and we kind of have to list what we know here, right? The 30 meters per second is actually the initial velocity, and that's actually the x velocity, because it's being sent in the horizontal direction. So what is the y velocity? Do we know what that is, the initial y velocity? Hopefully you recognize that if it's thrown horizontally, the initial y velocity is 0. That is to say, it's neither got an upward component nor a downward component when it's first thrown. And so as far as the y motion is concerned, it's like it was dropped. It's like the ring in the little demonstration. All right. The second thing we can notice is that if we call this y equals 0, the final position, and that means y naught is equal to 50 meters. That's what this is, right? And so now we know y naught and y and v naught y, and we're after t, right? And so we can look through these equations. We want to find t, so here's an equation with t, here's an equation with t, and here's an equation with t. We don't know the final velocity, so we can't use this one, and we would need the final velocity to get the average velocity, so we can't use that one. So that's our equation. We have y equals y naught plus v naught y times t minus 1/2 gt squared. Now maybe this won't work, but this is our best bet at this point. Notice v naught y is 0, and so that makes that one pretty simple. And y is 0 because it hits the ground, it hits the water at position 0. And so this leaves, if I move this to the other side, y naught is equal to 1/2 gt squared, and I want t. And so I can say t squared is equal to 2 y naught over g, or t is equal to the square root of 2 y naught over g, which is the square root of 2 times 50 meters over 10 meters, right, per second squared, sorry, which is the square root of 10 seconds squared, which is about 3.2 seconds. Get that all in there? 3.16 or something like that seconds. And so that's how long it takes to hit the water. I can then ask the question if I want, right? I can say, well, my next question is, how far did the ball travel horizontally? Right, and so now we're asking what this distance is. Its initial horizontal position is from where it was thrown. This is where it hits the water. And so if you remember your x equations, we had x equals x naught plus v average x times time, and then vx equals v naught x equals v average x, right? And so that gives us, if we rearrange that, we get x minus x naught is equal to v average x times time. But we already know what v average x is. It's the same thing as the final velocity or the initial velocity. It's 30 meters per second. And so this is 30 meters per second times 3.2 seconds, which is about 96 meters. That would have been question B. Right. And then we can ask another question. We can say like, what are its x and y velocities when it hits, right? And so we can say Vx, well, is the x component of its velocity is just the same as the initial x component of its velocity. And we already said that was 30 meters per second. Because if it was thrown 30 meters per second horizontally, that's the speed it's going the whole time horizontally, right? Vy is equal to v naught y minus g times time. That's our equation 2 up here, right? But we already said the initial velocity was just 0. And so it's moving at 32 meters per second, sorry, as a minus sign, because it's going downward in the y direction and 30 meters per second in the x direction, right? And so that would be question C. Sorry, I keep changing them at the very end, right? And so it's moving 30 meters per second this way and 32 meters per second that way. And we could then ask the question, we ask the question, what's the speed along its path? So it's got a Vx that's 30 meters per second, and a Vy is minus 18 meters per second, right? And those are those are the x and y components. V is equal to the square root of Vx squared plus Vy squared, and that's equal to the square root of 30 squared plus 32 squared. Well, I better do better than that, right? 30 meters per second plus 32 meters per second squared. And so V is equal to the square root of 900 plus 1024, so 1924 meters squared over seconds squared, or v is equal to .9 meters per second along the trajectory, along its path. So I'm going to give you a blow-up of right near the ground, right? It's coming in this way, and this is V equals whatever it is, 43.9 meters per second. It's got a y component that's Vy equals minus 32 meters per second, and a Vx equals 30 meters per second. Right. And so if we were looking at this angle, say, we could say, well, theta is the inverse tangent of 32 meters per second over 30 meters per second. I get about 47 degrees. Notice I didn't worry about the negative sign on here. When I make a triangle, I put a negative sign here to let you know that the velocity is going down. But once I've made a triangle, this is just, I can just think of this as a triangle, give all the sides positive values, and then I can calculate what this angle is. I'm not worried about the negative sign to calculate this angle. The angles interior to a triangle assume all the sides are positive, and so I don't have to worry about that. And we'll talk about this more as we go. Often in a problem, they'll want the angle relative to some particular direction, and so you might have to calculate this angle. The problem might ask you for this angle or something like that, and so you would have to subtract theta from 180. But if I'm not asked, I just take the absolute value of all the sides of the triangle, and then I use them to evaluate whatever angle I'm interested in. And so this one hits with an angle of 47 degrees, traveling at 43.9 meters per second.